Hi guys, I have a good news for you. We are going to deal with polarization, but we do not have to think about magnetic fields. So as we drawn last time, we draw electric field and then we draw these magnetic field lines to give a 3D effect. Very difficult to draw this, but guess what? We can ignore it. Why we are ignoring magnetic field here is because polarization is not getting affected by the magnetic fields. It is electric field which interacts with the matter or the material and results in polarization. So that is a good news. But I have a bad news too. Let's see. Now the bad news is we cannot simply think of a light going like this simple wave. Not only in this direction. So the electric field changes the direction. It goes into multiple direction over time. It is not restricting to y-axis as it moves. So that is a bad news. But how to deal with it? We have a solution. Don't worry. So first understand what trying to say. What I'm saying that over time, when this light passes, it may happen that it can come into the z-axis like this. And you can see drawing this kind of diagrams are very confusing. I'm not able to get the idea. So now first let's understand how we can show this changing direction of electric field. So let me draw this wave. Let's say electric field is oscillating like this, and you are standing here watching this wave going up and down, electric field going up and down. So for you, the front view is at this part goes up and down. That's it, right? Up and down. So what you will imagine is something like that. So this is a front view. So the electric field are oscillating like this. But as we said, it is changing direction. It can come to z axis. It can come at some angle. Now how to see that? So let's have z axis like this. And now how to draw z axis? Again, I will try to bend it like I was drawing for magnetic field like that. Right. But what about this guy now? He will be seeing the front view, but now I'm not able to show it here, but I can show in this picture how he will be able to see it. He'll be able to see like this. So over time, the electric field is not simply keeping one oscillation direction. It is going up and down and then right to left also, which I cannot show in the copy. But the front view person who's seeing the front view, he can see, oh, it is going up and down. And after some time, the electric field oscillates like that. And it can be other direction too. But first, let's play around this. So for example, I have a wave like that. I'm trying to show with my hand, right? So one way is if you see the side view, right? It is going like that. So that is what these curves are all about, right? This one, right? But let's see the front view now. So if my wave is going like that, if you become the person who is seeing the front view, so you will see something going like that. So if you notice at the tip of my hand, you are just seeing the electric field oscillating up and down. So this was this figure, this up and down. Now it is easier for me to show with these kind of diagrams different orientation. After some time, the oscillation changes. It was going up and down. Now it starts going like this. Now the tip of hand is going left, right, right. So that is what this diagram was about. This diagram. And now not getting into these kind of diagrams because they are hard to draw, but we can understand the front view very, very easily. Now I will make two more oscillations and let's see if you can guess with me what will be the direction. So you have seen this up and down. You have seen this going left, right. What about this? Like that. So now if you see the fingertip is going a diagonal, right? Diagonal. Can you draw the front view diagram here? So I was showing the wave oscillation, the electric field oscillation like that. Now, can we make in our hand gesture like this? How it will be? It'll be easy for you. Now it's just a game. So it'll be somewhat like that, right? The wave is going like that. And if you're seeing the tip, you're seeing it is taking this diagonal. So I can draw and I can visualize this, right? So that was a bad news that electric field of light which is around us, like coming from sun or a bulb in your room right now, it is unpolarized. The light is not in a fixed single direction. It is mixed. So the result will be, we can say the light is coming to us like electric field oscillates in this direction, in this direction, and this direction, and this direction. And this kind of light is called unpolarized light. The light we see around is unpolarized. It means electric fields oscillates in different random direction over time. As the time passes, sometime it will be like this. After some time, it can go like this, sometime after like this, and sometime over like that. So this kind of nature, if light has, we will say, oh, it is unpolarized. It has not having any specific pole. And now, what is the solution for it? So if we have unpolarized light like this, going in all the direction, electric field is oscillating in random direction. So can we polarize it? What I mean by that is, can I restrict it to oscillate in only one direction, just like that, up and down? So as of now, it is going like this, sometime after like this, and this, and this. What I want something in between so that it goes only up and down. Now think about it, how we can do that, right? So if I put a structure in between like this, right? So now think about it, which light can pass through? Only this will survive, right? Because it can pass through this slit. What about this? Can it survive? No, it will hit it. So it will not pass through. What about this one? This will also not pass because the orientation of this structure is like that. And guess what? We have certain materials. We have molecular structure like this where they only allow certain direction of oscillation of electric field. These are called Polaroids. Polaroids. So fancy word, but remember sunglasses? So what we did is we had unpolarized light. The electric fields were oscillating in multiple direction, and we converted them with the help of polarides to polarized light. Now the light is polarized. It is going in only in one direction. Remember poles like South Pole, North Pole? Now it only have two poles. It is polarized. And I can also change this structure. Let's say I rotate it and keep it horizontally. Let's see like that. If my polaride is like that, so only this guy will survive. This will be restricted. It can't go. This will also will not go, will not pass through. And result I will get is something like that. Something like that. Again, I have polarized it. So polarization does not mean that only vertically. You can polarize light according to your wish. You need to change the orientation of this polaride and you will get polarized light in a different direction. So this entire process where the unpolarized light is transformed, converted into a polarized light is called polarization. Don't worry, we will play around this and let's see this example. So my light, let's say it is going in this direction, left or right, and this direction also up and down. Let's take only two directions. So one is left and right and this up and down. If I put a slit like this, so only the left right will pass through, right? But this will get restricted, right? Because the orientation is like that. What if I keep it like that? If the structure or polaroid is kept like that, now the up and down will survive. It will pass through that slit, but not the left right one. It will get killed, absorbed by that material.